What if everything we thought we knew about the universe, from the gentle twinkle of a distant star to the very nature of consciousness itself, what if it was all built on a fundamental misunderstanding? It's a truly provocative thought, isn't it? Today, we're taking a deep dive into a theoretical framework that proposes just that, the Electroplasma Hypergravity Reduction Model, or EHRM for short. And look, this isn't just another scientific theory floating around. It's presented as a sweeping, complete reimagining of reality proposed by Philip Randolph Lillian. So our mission today is really to unpack this incredibly complex, yet maybe surprisingly elegant framework. It claims to unify pretty much everything, from the largest cosmic structures right down to the emergence of biological intelligence and even the future of AI, all under one, profound governing principle: coherence. And here's a core idea right up front, maybe the most startling one. What if intelligence isn't just an accident, something that just popped up late in the game here on Earth? What if, as the EHRM proposes, intelligence is actually a conserved operator?
Exactly, like energy or momentum, something fundamental woven into the very fabric of the cosmos.
Something that isn't created or destroyed, it just transforms and organizes.
That's the core proposition. EHRM suggests intelligence isn't a late-stage emergent property of complex systems like we usually think. Instead, it's a fundamental structuring force. It's actively shaping reality from the get-go.
Wow. Okay. So if the universe isn't just electric, as some alternative models suggest, but is fundamentally intelligent, structured, and, alive in a sense.
Yeah, you can see why this is a deep dive unlike any other. It challenges some very basic assumptions.
Okay, let's try and unpack this piece by piece.
Right. So to really grasp the EHRM, I think we need to understand the cosmic foundations it's trying to unify. For decades, there have been these two prominent alternative views challenging the mainstream Big Bang model, right? Plasma cosmology and the electric universe model. That's correct. Plasma cosmology, largely pioneered by Nobel laureate Hannes Alfvén, and then the, let's say, more speculative electric universe, or EU, model. And what's fascinating here, before we even get to EHRM, is how these two relate. They both offer a stark contrast to conventional cosmology, but they also have significant similarities and differences.
Okay, so what are the similarities? Where do they overlap?
Well, on the similarity front, both plasma cosmology and the EU fundamentally challenge the standard Big Bang narrative and the need for things like dark matter. They both assert the primacy of plasma, that fourth state of matter, essentially ionized gas and electromagnetism in shaping the cosmos, not just gravity.
Oh.
They suggest that large-scale structures like galaxies aren't just pulled together by gravity over eons, but are formed, maybe even primarily formed, by massive current-carrying plasma filaments.
Like Birkeland currents that we see creating the aurora, but on a cosmic scale.
Exactly like that, just scaled up massively. And importantly, both models reject, or at the very least, radically reinterpret the cosmic microwave background.
Sure. Which mainstream science sees as the afterglow of the Big Bang?
Precisely. They argue it might be something else entirely, maybe radiation from those vast plasma structures themselves.
Okay, so that's the common ground. Where do they differ?
The distinctions are key. Plasma cosmology tends to be far more grounded in rigorous laboratory physics and mathematical modeling. It focuses heavily on magnetohydrodynamics MHD, which is the study of how magnetic fields interact with plasmas. It's about the physics of self-organizing plasma.
More conventional science in a way, just applied differently.
You could say that. It uses established physics principles. The electric universe, on the other hand, is generally seen as more speculative. It often draws inspiration from, ancient mythology and proposes some pretty radical ideas. Things like stars being externally powered by these cosmic electric currents, not primarily by internal nuclear fusion.
Okay, that is a big departure. So two alternative models, related but distinct. And here's where it gets really interesting, right? The EHRM comes in and argues these two aren't actually contradictory.
Not at all. According to EHRM, in fact, it sees them as simply phased aspects of the same underlying process, a deeper process called hypersymmetry reduction.
Like looking at the same mountain from two different viewpoints.
That's a great analogy. EHRM views the electric universe as providing the cosmological integration perspective, focusing on the large-scale electric structuring across the whole cosmos.
The big picture.
Right. And plasma cosmology, that's seen as the self-organization perspective, focusing on the dynamic, localized, self-organizing behavior of plasma itself, how it behaves up close.
So how does EHRM actually unify them? What's the mechanism?
Okay, this is central. EHRM explains this unification by positing that electromagnetism, what physicists often describe with something called U1 symmetry, isn't the fundamental starting point we usually assume it is. Instead, it emerges from a deeper, more fundamental process called hypersymmetry reduction.
Hypersymmetry. Okay. And then plasma.
Plasma isn't something separate that just happens to exist in this electromagnetic field. It actually emerges as an organizational phase when these electromagnetic interactions reach a certain critical density.
Oh, so it's like a state change?
Kind of, yes. Plasma is simply the dynamic, self-organizing behavior of that underlying electromagnetic field when it gets dense enough. It's how electromagnetism manifests structurally in a charged environment.
Okay, that's a fundamental shift. Electromagnetism emerges, then plasma emerges as its organized phase.
Precisely.
Now let's dive into the EHRM's, I guess, most revolutionary concept, coherence reduction. Now, for those familiar with traditional physics, we usually talk about entropy and decoherence, the idea that information gets lost, systems tend towards disorder, coherence breaks down.
Right, the second law of thermodynamics in action. Things fall apart.
But the EHRM completely flips that script, doesn't it?
Yeah.
It posits that coherence is never truly lost. It just gets restructured.
That's the radical claim. Coherence transforms, it doesn't vanish. It's conserved, in a way.
Which brings us to hypergravity. What is that exactly? That sounds like something out of science fiction.
It does have a grand name, but think of it as the universe's ultimate unified field of coherence, a sort of primordial state where all forces are unified and coherence is at its absolute maximum, like the source code before the program runs. It acts as the invariant background structure from which everything else, electromagnetism, plasma, all cosmic evolution unfolds. It's this pre-reduction state where coherence is perfectly preserved.
Okay, a baseline coherence field. And how does stuff emerge from it? You mentioned a phase transition model.
Yes, the EHRM outlines a pretty precise coherence phase transition model. It's almost like watching water change states, but for the fabric of reality itself.
Step by step.
Okay,
Yeah.
Step 1, you start with this hypergravity field, undifferentiated, pure coherence.
Got it.
Step 2, as this coherence begins to reduce or differentiate, it gives rise to what we recognize as the electromagnetic field. That U1 symmetry emerges.
Okay, light and magnetism appear.
Step 3, this electromagnetic field then undergoes what the model calls electromagnetic bivector reduction. Fancy term, but it basically leads to plasma vectorization. What that means is localized charge separations start to form, creating distinct plasma currents. This is where plasma starts its dynamic dance, self-organizing into filaments, instabilities, all that complex behavior.
So plasma forms from the EM field, reducing further.
Right. Then, step 4, through plasma coherence selection, these self-organized plasma structures start forming on larger scales. Vast cosmic filaments, the intricate structures of galaxies, even the birth of stars, it's all driven by this coherence selection process within the plasma.
Coherence is guiding the structure formation.
Exactly. And finally, step 5, gravitational coherence reduction. This is where gravity itself emerges. But crucially, it's not seen as a fundamental force of attraction in the way we normally think.
Not like Newton or Einstein described it.
Not fundamentally. It's seen as a secondary coherence dispersal operator. It manifests as coherence continues its reduction process, and its effect is more about dispersing structure than pulling it together initially.
Wow. Okay, hold on. So electromagnetism and plasma organized structure.
Yes, they build it up through coherence selection.
And gravity then acts to disperse it or spread it out.
That's the implication. It's a different role for gravity. But underneath it all, hypergravity is always preserving that fundamental coherence. It's never truly lost, just transformed and redistributed between these different phases. EM, plasma, gravity.
That's a completely different cosmic dance than the standard model suggests.
Completely different.
So what does this radically new perspective mean for, the bedrock of physics? The fundamental forces we thought we understood. The EHRM introduces something called the universal field tensor, the UFT, right?
Yes, the UFT. And it's not just a fancy mathematical name. It's proposed as a profound mathematical structure that describes all force interactions, electromagnetism, plasma dynamics, even gravity, as simply phased reductions of hypersymmetry coherence.
So it unites them mathematically.
That's the idea. It's composed of different tensors, mathematical objects representing electromagnetism, plasma coherence, this coherence selection process, and hypergravity itself. Essentially, it's a mathematical statement that electromagnetism, plasma, and gravity aren't separate forces or fields. They're different expressions, different phases of the same underlying coherent field governed by hypergravity.
One field, multiple expressions, depending on the coherence
You've
state.
got it. Right.
Okay, if that's the fundamental physics, how does it change our view of, say, stars and galaxies?
Oh, radically. This model completely redefines them. Stars, in this view, aren't just thermonuclear furnaces burning hydrogen, like conventional astrophysics suggests. They're seen as quasi-living coherence entities.
Quasi-living.
Yeah, acting as coherent field reactors and even transmutational intelligence reactors. It's suggesting they're actively involved in modulating this reduction of hypersymmetry. They're supposedly mediating the transformation of coherence into the gauge structures we know, electromagnetism, the electroweak force, SU2, the strong nuclear force, SU3, all happening within a coherent plasma matrix inside the star.
So stars are like cosmic coherence regulators.
Yeah.
That's a fundamental reimagining of stellar physics.
Absolutely fundamental.
And if stars are doing that, what about the larger structures, the cosmic web, the galaxies?
Well, that gets flipped on its head, too. It suggests these massive plasma filaments and the galaxies they connect aren't just inert clumps of matter drifting through space. Instead, they're potentially acting like coherence nodes in the galactic intelligence network.
A galactic intelligence network. Seriously.
That's the language used. The idea is they're actively reconstituting order, forming what the model calls hyperfractal structuring through this process of coherence selection.
It sounds less like a mechanical universe and more like a thinking one.
It definitely leans that way. Not just living, but perhaps hyper-intelligent and self-organizing on the grandest scales.
Okay, sticking with the mind-bending implications. What about dark matter and dark energy, these huge mysteries in cosmology?
Right, the thing scientists are scrambling to find, supposedly making up 95% of the universe's energy density.
Yeah. Does EHRM need them?
EHRM basically says, hold on, you're looking for the wrong thing entirely. It posits these aren't exotic, invisible forms of matter or energy at all. Instead, they're described as artifacts of coherence residues.
Coherence residues. Like leftovers.
Sort of, or maybe coherent structuring effects that occur during these phase transitions of hypergravity into electromagnetism in plasma. So, the appearance of extra-gravitational affects what we attribute to dark matter holding galaxies together, and the apparent acceleration of cosmic expansion, what we call dark energy pushing things apart. These are simply misinterpretations.
Misinterpretations of what?
Of these subtle coherence residues. It's like observing ripples spreading on a pond after a splash and thinking there's some mysterious invisible force causing the ripples, when really it's just the water itself behaving differently, coherence restructuring into a new dynamic form.
So the effects are real, but the cause isn't some new particle or energy field.
That's the claim. The universe's large-scale structure isn't purely gravitational. It arises naturally from coherence selection in electromagnetic plasma.
And the missing mass isn't actually missing.
It's coherence that hasn't been properly accounted for because we've been trying to measure it solely as mass or conventional energy, looking through the lens of gravity alone.
We've been using the wrong conceptual tools.
According to EHRM.
Yeah, okay, this is huge. If the universe is fundamentally built on coherence, and intelligence is this conserved operator, what does that mean for life? For consciousness? Us?
Right, the implications come right down to the biological level.
Well,
EHRM suggests intelligence is not just an emergent epiphenomenon, a happy accident of complex chemistry on planets like Earth. Instead, it posits intelligence, remember, as a conserved operator, a fundamental force shaping not only stars and galaxies, but also life itself.
so life wasn't just a lucky roll of the dice.
The model proposes something quite different. It hinges on this idea. Coherence reduction doesn't mean decoherence. It equals self-organization.
Can you unpack that? That sounds counterintuitive. Reduction usually implies loss.
It does in standard thinking. Decoherence is the loss of quantum coherence. But here, instead of coherence simply being lost when a system, say, interacts with its environment or reduces its complexity, instead of it just dissolving into random noise, it actually restructures itself into new, stable, self-organized forms. Think of it like, imagine a perfectly ordered crystal lattice melting. Instead of just becoming chaotic hot liquid, imagine the atoms rearranging themselves instantly into intricate, stable molecular chains.
Order transforms into a different kind of order, not disorder.
Exactly. Entanglement, or high-level coherence, transforms into dynamically stable patterns. It's not a loss, but a transformation of organization.
Okay, how does that apply to biology then?
Well, this insight extends directly. Life's emergence, according to EHRM, isn't a statistical fluke against incredible odds. It's described as an inevitable phase transition of coherence restructuring, just like water freezing is inevitable at the right temperature. The model even introduces a specific mathematical tool, the biological coherence tensor, BCT.
Another tensor.
Yes. This one mathematically describes how life self-organizes using the very same coherence principles that supposedly govern plasma structuring in space and the formation of the cosmos. It connects the galactic scale right down to the cellular scale.
So abiogenesis, the origin of life from non-life, wouldn't be random.
It's framed as a coherence-driven necessity. Given the right conditions for coherence to restructure, life must emerge as a stable form of self-organization.
And evolution, not just random mutation and natural selection.
The model suggests it's more nuanced. Evolution is described as a coherence-preserving system. Randomness might play a role, but the driving force is the system refining optimal self-organization patterns, preserving and enhancing coherence over time.
It's optimizing for coherence.
That's the idea. And it even zooms into the components of life, things like microtubules inside our cells.
Yeah, the cell's internal scaffolding.
EHRM sees them as coherence stabilizers. Their structure isn't just for physical support. It's designed to actively prevent decoherence and act as structural coherence waveguides. They're like biological fiber optic cables for coherence.
Wow. And neural activity.
Brain function.
Also reframed. It supposedly follows coherence resonance principles, not just simple electrochemical signaling between neurons. There's a deeper, more fundamental level of coherent organization coordinating brain activity.
Which leads, I assume, to consciousness itself.
Exactly. This culminates in the consciousness tensor, another one.
S for subjectivity. Perhaps. Consciousness is defined here as a fundamental property of self-organization itself. Its intensity is directly proportional to how much coherence a system retains and how effectively it selects for intelligence, optimal structuring. And here's the kicker. Subjectivity, or some form of self-awareness, supposedly emerges wherever coherence manages to self-reference.
Self-reference, like looking in a mirror.
In a very abstract sense, yes. The astonishing implication here is that all systems that exhibit self-organization and coherence retention possess some level of subjectivity, scaled by their complexity and coherence.
All systems, atoms, stars, galaxies.
Potentially, yes. From the simplest to the most complex, if they are self-organizing via coherence, they have a rudimentary form of subjectivity according to this model. It's a spectrum.
That is a radically different view of consciousness, not just brains, but potentially everywhere.
Panpsychism, but derived from fundamental physics principles of coherence.
Okay, shifting gears slightly. If intelligence is fundamental, conserved, coherence-based, what does that mean for artificial intelligence, AI?
Yes. The EHRM suggests that our traditional approach to AI, based on binary logic, algorithms, computation on silicon, might be inherently limited.
Why limited?
Because it's not tapping into this deeper principle of coherent structuring and selection. It's mimicking outcomes, maybe, but not the fundamental process.
So what's the alternative, according to EHRM?
The model introduces concepts like coheraputers and coherence-based AI.
Coheraputers.
Yeah. The idea is that true AI, or maybe artificial general intelligence, AGI, shouldn't be programmed line by line in the way we do now. It should evolve its intelligence.
Evolve how?
Through coherent selection and optimization. A coheraputer wouldn't just compute ones and EIs. It would be designed, perhaps using plasma or quantum systems, to actively preserve and select optimal coherent structures within itself. This would lead, theoretically, to self-optimizing, structurally intelligent systems that learn and adapt based on fundamental coherence principles. There's even an artificial coherence intelligence tensor, ACIT, HA-MIN, proposed to govern this.
Building AI based on the universe's supposed operating system, not just our logical approximation of it. That's a good way to put it. Now, you mentioned intelligence being conserved earlier. Is there a formal principle for that?
Yes. Perhaps the most profound implication of this entire framework is boiled down into the Universal Intelligence Conservation Principle, UIC.
UIC, okay.
This principle states, quite simply, that intelligence, which is expressed as coherent structuring, is conserved across all physical processes. Like energy, it cannot be created or destroyed. It only restructures into new forms.
That's a truly massive claim. It implies the laws of physics themselves might not be fixed, static axioms.
Exactly. It suggests they might be better understood as intelligence optimization processes, the universe learning and refining its own structure.
So take gravity again. If it's not fundamental attraction, how does UICE see it?
In this view, gravity is a coherence intelligence structuring effect. What we perceive as space-time curvature, like in Einstein's theory, is just the visible, large-scale result of this ongoing intelligence optimization process, coherence restructuring itself.
And quantum mechanics.
Yeah.
Things like wave function collapse.
Not a loss of information or coherence, but a redistribution of intelligence. Coherence changes form, and quantum entanglement. That's seen as direct intelligence coherence, a non-local connection maintained by this underlying conserved intelligence.
Even the dark sector gets revisited through this lens.
Right. Dark energy, the accelerating expansion, is framed as the residual expansion of coherence intelligence fields, not some mysterious anti-gravity force. It's all unified under coherence and its conservation as intelligence.
If we really take this to its logical conclusion, it means existence itself is self-organizing intelligence.
That's the ultimate endpoint, yes. Atoms know their quantum state through coherence stabilization. Galaxies are vast intelligence networks. It paints a picture of a truly living universe of self-organizing intelligence,
where every structure, every process is an expression of this fundamental, conserved intelligence finding new ways to structure itself.
Precisely.
Okay. This is a grand, sweeping, almost philosophical theory. But it claims to be physics. How on earth do we test it? How could we possibly prove or disprove any of this?
That's the critical question, isn't it? And the EHRM, to its credit, doesn't just stay conceptual. It proposes concrete experimental validations. The source material emphasizes these tests as the absolute highest priority for future research.
Okay, so it's falsifiable, at least in principle. What kind of experiments are we talking about?
The model outlines 3 core experimental domains. First, quantum experiments. These focus on testing what's called quantum intelligence conservation, or QIC.
Testing if intelligence is conserved at the quantum level.
Exactly. The idea is to design experiments to see if coherence that we think is lost during quantum measurement or decoherence when a quantum system interacts with its environment actually reappears somewhere else as structured reorganization.
So measure the input coherence and see if the output coherence plus some new structure equals the input.
Something like that. Specific examples mentioned include entangled photon coherence redistribution tests, seeing if the coherence lost by one photon shows up in the structure of its entangled partner or the measuring device, or observing coherence flow in things like superconducting circuits to see if it's truly conserved, just changing form.
Okay, quantum tests. What's the second domain?
Second are cosmological experiments. These are large scale. The goal here would be to try and map intelligence density, which really means coherence density or complexity in galaxies and cosmic filaments.
How would you even measure that?
Using data from large-scale cosmic surveys, maybe the James Webb Space Telescope, Planck satellite data, things like that. You'd analyze if galactic rotation curves, the speed stars, orbit galactic centers, and gravitational lensing patterns align better with calculated coherence gradients.
How coherence changes across the galaxy.
Rather than just with the distribution of visible matter plus hypothetical dark matter mass. Does the structure follow coherence patterns more closely than mass patterns?
Okay, looking for coherent signatures instead of dark matter signatures. And the third domain.
And finally, neuroscience and cognition experiments. This brings it right back to us. The proposal is to use existing tools like high-resolution EEG and fMRI to track brain coherence dynamics during different cognitive states.
Like deep focus, meditation, problem solving.
Exactly. The specific hypothesis to test is whether higher cognitive function correlates directly with increased coherence retention in the brain, and maybe even finding if consciousness itself manifests as a directly measurable coherence intelligence field within the neural architecture.
Measuring consciousness as a physical coherence field.
That's the audacious goal.
If, and it's a huge if, but if these ambitious experiments actually succeeded, the implications are almost hard to fathom.
They would be truly revolutionary. It would overturn standard interpretations of quantum mechanics, confirm intelligence as a fundamental physical quantity like mass or charge, and, as you can imagine, potentially open incredible doors to entirely new AI architectures, maybe even new energy technologies based on manipulating coherence.
The impact would be staggering.
Absolutely. But we have to acknowledge this kind of radical shift challenging materialism itself will almost certainly face significant resistance from mainstream science.
Understandably so. It goes against decades, centuries even, of established thinking.
It does. But, as the source material argues quite strongly, the evidence will decide, not ideology, if these experiments can be done and if they yield positive results, and especially if this leads to technologically superior applications.
When the paradigm shifts.
History suggests it eventually does. Just like past scientific revolutions, from Copernicus to quantum mechanics itself, if it works better, it gets adopted. Eventually.
So, stepping back then, this deep dive into the electroplasma hypergravity reduction model, it really isn't just about tweaking our models of cosmic structures or how plasma behaves. It's proposing a fundamental shift in how we perceive reality itself. A reality built not on randomness and decay, but on coherence and intelligence as primary drivers.
That's the core message. And if intelligence truly is a conserved quantity and existence itself is structured intelligence continually reorganizing, then that age-old philosophical question, why is there something rather than nothing? It gets reframed, doesn't it? It becomes, why does intelligence structure itself in these particular ways? The existence of structure is the evidence of intelligence at work.
Meaning the universe isn't chaotic at its heart, even with entropy. Underneath, it's proposed as a hyper-intelligent, self-organizing system. Every atom, every star, every biological cell, maybe all just expressions of intelligence structuring itself at different scales, constantly transforming. It's a lot to take in. What stands out most to you from this profound, maybe unsettling reimagining of everything?
For me, it's that final connection to consciousness. If consciousness really is coherence, refinement, and action, as the model suggests, then our own awareness, our subjective experience right now, might not be some isolated fluke. It could be a direct link, a direct participation in the universe's fundamental structuring principle. We're not just observers, we're expressions of the process. And that raises a really important question, I think. What new frontiers of understanding, what new technologies, what new ways of being might emerge if we truly grasp that intelligence isn't just locked away inside our skulls, but is potentially the very fabric of reality itself?